Hi guys, in this video we want to prove the sine compound formula. The idea of the proof is to express the area of this triangle by two different trays, using only AH, which is the side AH, and angle beta and alpha. Pause the video, try to find two different expressions for finding the area of this triangle, and see how far can you go. So assuming that you have paused the video, let's try to come up with the first expression to find the area of this triangle. The obvious way is to express the area of the two smaller triangles, namely this triangle HCA and triangle BHA. The way we can express the area of those triangles is by using the formula half and the base, which is HB times the height AH plus half the other base, which is CH, times the other height, which is H. In this expression, there's two things that we don't know the value of, that we don't want to appear in the expression, namely HB and H and CH or HC. How can we find it using just the angle and the side or the length of AH? We see from the first triangle that tan of alpha is equal to opposite, which is HB, divided by adjacent, which is AH. This implies that HB is equal to tan alpha times AH. Similarly, for HC can be written as AC tan of beta. So we can substitute their values back. This thing will be equal to half HB, which is AH. Since there's another AH, this will be AH squared. Let's factor AH from both expressions because there will be here AH. So this thing will be AH. Since both of them will have AH and there is another AH over there, so there will be a factor of AH square and there will be another factor of half. What's left is tan alpha plus tan of beta. So this is the first way in finding the expression of the area of the big triangle. There's another way which looks somehow, this is not counterintuitive, but it's something that takes a while to figure it out, maybe, is that we can actually make another triangle. It's not another triangle, adjustment to the triangle. So we do a perpendicular from a point C to some point over there and find its area of the triangle using the formula half the base, and the height in this point will be C till that point, and let's call it the point B. So another way to find the area is using half times the base, which is AB, times the sine of theta. In this case, the sine of theta will be this whole angle, which is alpha plus beta, because this is a right angle for this is a right triangle, where this is the hypotenuse. So that thing will be the hypotenuse, which is AC times sine of the angle, which is alpha plus beta. However, as I said in the beginning of the video, we want to express everything in terms of AH. The two things that we don't want, they are AB and AC. So let's delete the triangle or the thing that we made. We will find something. We will find that AB in the first triangle, that AB is the hypotenuse of the first triangle. So because we want the relationship between the adjacent and the hypotenuse, we will use cosine of alpha will be the adjacent side over the hypotenuse. This implies that the hypotenuse is equal to AH divided by cosine of alpha. Similarly for AC, it will be the hypotenuse for the second triangle. So AC will be equal to AH divided by cosine of beta. So putting everything in the expression here, we will get that this thing will be equal to half AB, which is AH, and since there will be two AH, so this thing will be AH squared divided by cosine of beta cosine of alpha. So since the dimensions are correct. So we found two ways in which we express the area of the triangle. Since both of them are for the same triangle, both of them must be equal. So this thing and that thing must be equal to each other. So let's ways to find some space. Let's erase the beautiful triangle. So this is the first way in which we express the triangle. This is the first way, this is the second way. Let's equate them together. So the first way is half AH squared times tan of alpha. Let's see what's tan of alpha. Tan of alpha is sine of alpha divided by cosine of alpha plus tan of beta, which is sine of beta divided by sine. So sine of beta divided by cosine of beta. This is the first expression, every expression after expressing in terms of sine and cosine. And what's the second way of expressing the area, which is that thing, which is half AH squared divided by cosine of alpha times cosine of beta. Let's make more space. We will see something that actually we can cancel the half and the half. We can cancel AH squared from both sides. And if we did not, so I forgot here, this should be sine of alpha plus beta. I probably didn't copy it from the expression, so there will be here sine of alpha plus beta. If we multiply both sides by cosine of alpha, cosine of beta, sine of alpha plus beta will be equal to cosine of alpha, cosine of beta times sine of alpha, cosine of alpha plus sine of beta, cosine of beta, which will become sine of alpha cosine of beta plus sine of beta cosine of alpha. So this is the compound expression for the sine of alpha plus beta.